What we got in the workshop today is a Gardenline 8846 petrol mower. They are sold by ALDI. They've actually moved on to an overhead valve model now. This is the side valve model. It's the first time I've dealt with one of these, so it's going to be an interesting experience. I can find nothing online as to tune up specifications, so it'll all be guesswork, so it gets even more interesting. But you might own one of these. This one's in to get a service, a bit of a tune up. It's been working for quite a few years now, and it's winter here in Australia, but it's coming on to spring and it's going to be needed to be doing some work by its owner. So, let's see what we can find. Hello, I'm Bob and welcome to yet another episode on the White Dog Garage YouTube channel. The motor looked to me like a Briggs & Stratton unit, and cleaning some dirt off I discovered the company's nameplate on the fuel tank, so I was right. Around the front of the motor I could see the engine details. The mower is made in China, and guess what? Briggs & Stratton have a Chinese manufacturing plant, making not only motors, but also mowers. Interpreting the model numbers, I can tell it is a 158 cubic centimetre vertical shaft motor, and the service details for it are shown here in this table. I'm going to start by taking off the cowling, mainly because I just want to have a bit of a look at this one, which is all a bit loose. Australia changed to the metric system in the 1970s, and consequently there is an assumption that stuff sold here will conform to the metric system. But I'm increasingly finding that some of the Chinese equipment imported into Australia, and we do import a lot of stuff from China, conforms to the imperial system. This Chinese-made motor mower is an example of this, having all its nuts and bolts in imperial inch dimensions. The threads being mainly Unified National Course. Of course, the home of Briggs & Stratton is the United States of America, so why not? So heads up, for working on one of these mowers, you will need spanners and sockets to suit the following imperial across the flat sizes of 1/4, 5/16, 3/8, 7/16 and a 1/2 inch, plus a 13/16 of an inch plug spanner. Taking the slack out of the starter cord is just a matter of rotating the pulley spring assembly under the cowling to retension the starter pulley and then reinstalling the cowling back on the motor. Not thinking ahead to other jobs I need to do, instead trusting my faulty memory rather than having a list, this will not be the last time I remove and replace the cowling on this machine. These are the basic service and tune-up jobs that I'll be doing on this mower. For the engine, I'm going to check the valve clearances, replace the spark plug, service the air filter and replace the engine oil. After that, I'll check for any loose or missing bolts and check the blade condition, replacing if necessary. So the first thing we'll do is take off the exhaust guard. The cover of where the valves are, or the valve lifters, is behind the exhaust. Push the lock tabs down first. There we go, there's our exhaust off. And behind this cover here will be where you check your valve clearances. 1/4 inch. I have a little magnetic tray, catch all my bolts that I undo. So if you look here, this opening here is for the breather. You need to keep your crankcase pressure down, and the other thing is, rather than bent to the atmosphere, it's probably going across to the carburettor and being fed back into the fuel, which is the modern standard for emission controls. So there's the spark plug. Bit of oily deposits on the outer rim, but the electrode looks reasonably clean. You'd almost think this might have been changed because usually in Chinese made it's a torch spark plug, but this is an NGK BR2-LM. I think we have one of those in stock. Looking at the valve chest, the top valve is the inlet and the bottom is the exhaust. Valve clearance is checked when the piston is at the top of its stroke, having compressed the air-fuel mixture. This is also known as the compression stroke. Valve clearance is measured by inserting a feeler gauge in the space between the top of the tappet shaft and the valve stem, indicated here by arrows. There's no indication of where top dead centre is, but I'll show you how we find it. So if we rotate the motor, and what I'm doing is I'm turning the blade at the base, and somewhere here. So that's the exhaust there, and the exhaust is opening, and it will close when I get the motor turned a bit more. And that's the inlet opening now, and it's closing, and this is where the piston will be coming up to top dead centre. So what I'm doing is I've got a screwdriver, I'm putting it in the spark plug hole, and as I rotate the motor, or rotate the blades, the piston is coming up. So we've just closed on the compression stroke, and when the screwdriver stops being pushed out, we're at top dead centre, and that's where we go to measure our clearances. Valve clearances for this motor are, for the inlet, 0.13 to 0.18 millimetres or 5 to 7 thou, and for the exhaust 0.18 to 0.23 millimetres or 7 to 9 thou. I will start by checking the inlet clearance first. We go in with the small one first. It doesn't go in at all. That's very interesting. The upper end of this, 0.18 millimetres, is the exhaust minimum. It doesn't go in either. The owner said it's hard to start, and I'd say we've got some valve seat recession there. There's no adjustment on the valves in these. To adjust the clearance, what you have to do is grind the valve stem, the top of the stem down, to give yourself some clearance. So it's all a bit more complicated than I was hoping for. So what we found is we can get a 2 thou feeler gauge in there. We can't get a 3. So we've got 2 thou there. And it's a tight fit on the exhaust at 6 thou. The valves are located beside the cylinder in this motor, not in the head. But to get them out, you must first remove the head. The retainers holding the valve spring in place consist of a metal disc with an elliptical hole running from the centre to one side. The diameter of the ellipse at the edge of the retainer is bigger than the valve stem diameter. The smaller central end locks into a groove on the valve, holding it in place on the spring. Forcing the retainer to the side brings the valve stem into the larger end of the ellipse, releasing it. Briggs & Stratton may have a special tool for this purpose, but I'm using a screwdriver and pliers to release the retainer from the valve stem. This is the valve retainer. This is how it passes over the top of the valve stem and then locks into a groove to hold the valve spring in place. With the exhaust valve out, the inlet valve is removed in the same way. Actual valve clearance was 0.05mm for the inlet and 0.13mm for the exhaust. So I need to remove 0.1mm from the stem of the inlet valve and 0.07mm from the stem of the exhaust valve. These amounts are very small, not something you should attempt to remove with an angle grinder. The slight reduction in clearance caused by the receding of the valves also needs to be borne in mind. The valve stems are hardened steel alloy and the tops need to be ground down. I don't have a surface grinder and instead will be using a pink aluminium oxide grinding wheel mounted in an ER32 chuck on the HAFCO HM45 milling machine, and I'll be running it at 1600 revs per minute. First, I am squaring the face of the pink aluminium oxide grinding wheel by lowering it past an industrial diamond tipped dresser held in a 5C collet block. Pink aluminium oxide is made of chrome corundum, which has a high hardness and is suitable for precision grinding and form grinding of hardened steel, alloy steel tools, measuring tools and instrument parts, so it's perfect for the job at hand. A high level of accuracy is required here. I have mounted the valve in a 5C collet block. I bring the grinding wheel up with zero backlash to wedge a 0.1mm feeler gauge leaf between it and the valve stem. I remove the leaf and adjust the table 0.1mm plus the amount to be removed. Locking the table in the X direction, engaging the grinding wheel, I go back and forth across the top of the valve stem. Having measured the valve length with the micrometer before starting, I then re-measure it again to determine the amount removed. Remembering that the valve stem length can always be reduced further but cannot be made longer, a slow and steady approach is the way to go here. After grinding, the reduction in valve length is 0.117mm for the inlet valve and 0.083mm for the exhaust valve. Both these amounts are slightly more than the reduction target, although that value does refer to the amount needed for adequate clearance, not the valve length. I'm still not concerned, however, as the values are close enough. The valves still need to be lapped in, and this will also reduce the final clearance by a small amount. Lapping the valves involves putting grinding paste on the valve face and positioning it against the seat. The valve head is then rotated using a rubber suction cap on a stick, otherwise known as a valve lapping tool, like is shown here, and this is used to grind the face against the seat to provide two matching mating surfaces. Once the valve faces are ground in, I clean both the valve and the port and remove any grinding paste or residue. So if you don't have one of these, you can try anything. You really just want to turn the valve. So this is just a magnet out of a speaker, and I just put it on there and it does the job just as well. It's just about turning the valve, letting the grinding paste do its work in setting the valve. And pull the valve out, have a bit of a look. What we want to see is a nice grey line around the circumference. No dimples, no ins and outs or particular waves in it. And looking at the seat of the valve, you want to see that it's a nice even line around it as well. Refitting the valves can be a bit of drama. Remember that the valve retainer has a large opening to one side through which the top of the valve stem passes, and then the retainer locks into the groove on the valve stem to hold it in place. With the valve partially inserted in its guide, I position the spring and retainer in the chest with the large opening over the follower or tappet. And finally I have it in place. And what I ended up doing is just pulling the spring back and prising the retainer across and then grabbing it with the needle nose pliers, pulling it further and then pushing it in to place. So all I've got to do now is confirm that the exhaust valve clearance lies within specification, which is between 0.18 millimetres and 0.23 millimetres, or 7 and 9 thousandths of an inch. So we go in with the 0.18 first. That makes an easy passage in, and we go in with the 0.23, and you can feel it actually push the valve slightly out. So it's all good. We have done the job. We've given the motor some valve clearances. Now it's just a process of putting it back together. Just need to remember that that goes there. These are 1/4 of an inch. Reinstalling the head is the reverse of removal, of course. All the head bolts are the same, so it really doesn't matter which position they go in. So doing up the head bolts, 16 Newton meters. Now, the way I do it is I give them a little touch up first. You'll notice that I'm going more around the head than I'm around the valve chest. Okay, so you can do patterns. There probably is a pattern in a Briggs and Stratton book somewhere, but the way it works is that you can go opposites. You can go every second one, or you can go in a spiral. I tend to go in a spiral. So I'll start with this one here, and then I'll go up to this one, and then I'll this one. Spark plug's ready to go in. I've set the gap, it's 0.76 millimeters, 30 thou, and I've put some anti-seize on the thread, which is what I like to do, so they're never sort of locked in. This mower is equipped with an extra handle which you pull in, and that allows you to start the motor and actually use the mower for mowing. The owner's asked me to do something with it. As you can see, he's had a bit of rope here which he ties it back. He finds it a real nuisance because it shuts the motor down when you go to empty the grass catcher. It shuts the motor down when you go to move something that's in the way of the mower. And it's been hard to start, and that's generally upset him as well. So what happens is you pull the handle in, that allows it to operate, but what it does is it takes the contact away from the flywheel, which is connected by a wire that runs to the magneto. Now, it's not a common feature these days. It's the first one I've ever seen, but obviously the manufacturer thought it would be a nice little safety feature. So what I'm going to do is undo and remove it. So there's the offending beastie, all off. All I got to do now is deal with the handle, which I'm hoping is as simple as this, which is just pulling it out, and there we are, all gone. No more stopping, no more holding it on with a piece of rope. And I suppose we'll do the right thing here and take the rope off as well. The air cleaner sits under this cover. It's a flat bladed screwdriver, lift it off. That's all looking pretty sad in there. But why I've taken it off is I want to check the air gap between the magneto and the flywheel. So what I want to do is check the air gap between the magneto and the flywheel. The gap is supposed to be 0.15 to 0.25 millimeters. So we've got a 1.5 and a 0.25. You just come in the side, and we're pretty tight there. And come in the other side, we're nice and loose. Just have another check on that one. No, we're definitely too tight at 0.15. So we're going to have to adjust the air gap. What we do there is we just undo the bolts, and it will move slightly. My workaround here is to pull in a 0.2 millimeter feeler gauge. I put the 0.2 millimeter feeler gauge in, and I do it up slightly, and I go around here on this side, pull it back, put the 0.2 in again, then do up the bolt, do up this one as well. Righto. Pull that out. We're running between 0.15 and 0.25, so we'll check that gap. 0.15 fits in nicely. 0.25 doesn't fit in. 0.15 fits in nicely. 0.25 doesn't fit in. Okay, so we've set the air gap. The air cleaner on this one, pretty foul. They're an oil and foam one. Doesn't look too good at all. And what I'll do is replace it, I think. This is the remains of the old air cleaner filter. They're just a foam filter. They're supposed to have oil on them. This one's just perished with age. Wouldn't have helped the motor either. Anyhow, we're going to replace that. It's an oil and foam filter. So you start off with foam and then you have to oil it, and I'll show you what you do. I just use a foam filter oil. So what happens is, this is the new filter here, and drop it in, and I will just give it a good douse of the oil, and then I work it in. So that I get a good penetration of all the foam. Now, how it's meant to work is that you obviously draw air through the foam, and that will help to keep the dust and dirt out. And you get a lot of dust and dirt with lawn mowers, but the oil just provides that extra glue, if you like, to trap the dirt. And of course, you should service them at least yearly. It just means cleaning them out and re-oiling them. They last quite a while compared to paper filters. So that's pretty good now. We'll install it. And those holes there are essentially the air intake, and then it comes over the top and goes down into the carburetor. Carburetor itself, it's got some baffles here, just a little extra, holds the foam away from the air intake, and yeah, it's got some baffles here that holds the foam away from the air intake. Let's give that a bit of a clean before I put it on. That's the air filter done. We've done the spark plug, checked over the motor. We're pretty well ready to change the oil. I'll put the cowling back on the motor first. Now, the recommended way of changing the oil in these is to merely tip them on their side and have the oil come out of the oil filler hole. On a lot of the motors there's a sump plug underneath which you could undo. Hopefully the owner won't watch this video. Thick black gungy stuff. I don't know why people don't understand that motor mowers require maintenance. What I put in them is 30 weight mineral oil, premium Penrite mineral oil. Not that I'm spruiking the brand. So the last bit of the service tune up is just have a look at the blades. They're in pretty good condition. If you don't hit too many rocks, it all works out. It's all a bit rusty under here. Doesn't get much cleaning, I would imagine. And you do have the problem of grass and water, and we've had quite a wet year. It's a pretty corrosive environment. Other than that, it looks pretty good. If I don't like the edges of the blades, I have been known to just get my angle grinder out and just tune them up a little bit, but these are not too bad. A bit of grass cutting still left in it. Unfortunately, this is going to be the end of this episode. I had intended to show you the mower starting up and stopping, but I didn't seem to get the email about actually videoing that process. The mower's long since left the shop, so I don't have any video of that, and I apologise for that. Still, having to deal with negative clearance or negative valve clearance, that was quite something. I've worked on a number of Briggs & Stratton motors over the years, side valve Briggs & Strattons. The small ones don't have any facility for valve adjustment like this one, and this is the first time I've actually encountered negative clearance. I've had a few go close, and the only way of dealing with that in this situation is to grind the end of the valve stems, which worked out well for this motor. Anyhow, thanks for watching, and I look forward to talking to you on another episode from the White Dog Garage YouTube channel. Thanks again. Bye.